ability to say with conviction that this particular response is grounded in the source data that was provided. Fluency is all about correctness of English language. Coherence is what is the probability of humans interpreting the response that was generated, and of course, relevancy. And this is really going to be an iterative process, but to start with these all with respect to the pre-trained model, these benchmarks are available and you can start exploring that. And we'll show you demo as we go ahead. So that's first one is about models and choice of models and evaluation. The second is all about information or the knowledge and search. What kind of information will help really help my users, and how can I ground Copilot on my data? Ground is just another word for saying that stay truthful to the source data or enterprise data that I'm going to be providing for my enterprise Copilot. So that being the customer asked, how do we really solve for bringing the domain and enterprise data knowledge to these large language or small language models? Given we know there are challenges with the LLM, they are trained as of some data that is acquired, and the newer models are of course becoming more and more recent. The second is it is trained on internet, data. So having knowledge to both domain knowledge it has, but not the enterprise data knowledge. And these are different ways you can actually ground or bring enterprise knowledge to your Copilot or to LLM. The first is prompt engineering, which is in context learning. The second is in context learning is without training or without augmenting with additional data. You're just changing the way you give instructions to the LLM and it performs better. Like if I'm building a customer service bot or the bot that is sitting on my website, I say, hey, your job is to only respond to questions about brand Microsoft and not about any competitor. So that's really is what we say in context of prompt engineering. The second is retrieval augmented, where we want to bring new facts or new knowledge. And the third is fine tuning, where you build or learn new skills altogether. Now, again, in terms of value chain, this is how you should be looking at customizing your language model, and what we've seen working within Microsoft with our customers. Given we've seen broad set of use cases now from our own copilots to customers building. The first is of course combination of prompt engineering and using RAG, which is retrieval augmented, and that's going to take care of 90% of your use cases, 90 or even more. So you of course need to do prompt engineering always. You should bring in your enterprise scenario, unless it is really a bot which is just a travel and some bot which needs to address bases the internet knowledge again, but that's never going to be the case. So yes, these two are fundamental to building your custom Copilot. But then after that is fine tune, where you take a foundational model like GPT-4o or GPT-4o, but make it learn on your own data, change the behavior, learn new weights in a very optimum way. So you're not building a LLM from ground up. Your requirement for label data will be much lesser, but you can still in the out-of-box LLMs. Having said that, we've seen that as models are getting better, the need of fine-tuning is reducing further and further. And a year back, some customers who built, fine-tuned models, whatever capability that they could achieve now is available out of box, because GPT-4 and 4o have become significantly better compared to last year when GPT 3.5 was the case. And then custom is where you literally build a model from scratch. You need to bring entire data, you need to define the architecture, etc. So in terms of value chain, again, you can see the time required increases, the skill required increases. For building a custom LLM, you need to have deep data science skills, understanding, building LLMs, the deep learning architectures, the transformer architecture, etc. And then, of course, the platforms like PyTorch, etc. Likewise, your requirement for compute and training data goes up. So, however, like I said, more complex may not always be the best, and you may be able to manage 90 to 95% of the scenarios using out of box prompt engineering and using the retrieval augmented generation. Now, let's look at what is retrieval augmented generation, because that really is crux of building your enterprise copilot or custom copilot as we call it. The benefit, of course, you can see here in access to internal knowledge, up to date public knowledge. Um, but what really happens here is you have your, in terms of workflow, there is an application UX, user request, basically asks the question. The question goes to orchestrator, and orchestrator is super critical component in this architecture. You will understand more as we go forward. Orchestrator is really, ensuring that right messages are passed to the LLMs, right information is retrieved to generate modify the prompt, and then passed on to the LLM. So as a first step, it gets the user question. It sees, do I need to retrieve additional information? It retrieves that from backend sources. That could be a search index, it could be a database, and that's really is the retrieval system. Once it has searched for relevant data, the top results are retrieved to orchestrator. Now it sends all of that, rather it creates a dynamic prompt with user prompt and retrieved information, sends that to the large language model like GPT-4o, now generates the response, comes back to orchestrator, and their information is sent back. So that's really at a very high level the workflow is. You'll see the detailed architecture below. But if I may just further break it down, so query my data goes to search index, gets the results, query model different choice of models, and yes, the orchestrator can also decide for different kind of tasks. It can send responses, or rather the request to different LLM models. Like for some cases, SLMs may be there. So your solution may be actually built using multiple models, and eventually there is a state and context need to be managed. The memory needs to be managed, because you're not just asking one question and getting out there. You're building a full task workflow using these copilots, which are able to carry out a business task for you. And hence, for that, it needs to have a multi-turn conversation with the user, with the ability to manage that state, context, and memory. So this is really what happens. If I take an example like this, user has given, there is a system prompt which, as a designer, you are defining, or as a developer or the business, you're defining that you are an intelligent assistant helping Contoso employees with questions about their healthcare plan, what is included, etc. So user query in this case is, does my health plan cover annual eye exam? Now, in absence of no other data, if we just use out-of-box models, like even GPT-4o, it would say, hey, I don't know about your health plan because my information is about public internet and I can't, respond. So at that time, the orchestrator is going to bring in data, relevant data, retrieve the relevant data from the backend sources. In this case, AI search, which is, hey, give me top 3 results related to eye exam in the health plan or the health policy which exists for employees. Get that information and the response is generated. So this search and retrieval is what we call as a retrieval augmented. Now, going from search, let's understand what really is relevant. So we retrieve the knowledge, but it is important to understand that quality of retrieval is as important as retrieval, or rather more important. You probably do not want 100 search results being thrown at you. You want a very precise answer, but at the same time, your documents, it will not be sufficient just to do a keyword search, like looking for lessons for on underwater activity. You also want to match here with scuba classes or scuba diving, snorkeling sessions, etc. That's really the semantic meaning, and we need to ensure that not just the retrieval technology, but search capabilities that you use are able to also understand and provide semantically relevant responses. And that's really where embeddings and semantic similarity related search comes into picture. Embedding is nothing but you use one of the APIs, for example. For all the LLM models will provide embeddings, but in our case we have embedding 2 and 3 APIs on Azure OpenAI. That creates a array or a vector. It's just a vector of n dimensions, and that being so every word becomes an embedding or a vector. And then semantic similarity is about identifying vectors who are close by in that multi-dimensional space. The multi-dimensional space is actually each word is one vector, right? So all these words become dimension in that multi-dimensional space. So what you see on the right hand side is really a way to identify what are the similar looking vectors or embeddings, and that's how you identify the relevant document. So if I just take an example of vector embedding in the two-dimensional space. So you can see king being represented as 4 and 5, two different on the two-dimensional XY axis, man being by 3, 3.5. And if likewise, if we map them in the XY space, you can see that similar words like king, man, woman, they all represent something similar, which is human beings, and hence they are represented together in the two-dimensional space. Apple, banana, oranges are all fruits and hence presented together, and likewise sports items or sports itself. Football is more closer to golf than to orange or apple. That's clearly the differentiation between the two. So that's what vector embeddings enable for us to find similar or closer documents. Now, how does it really play out in case of identifying most relevant or semantically relevant search results, not just keywords? So keyword search example could be, hey, I'm looking for a person's phone number. Of course, in that case, you want a keyword, but not every single time, that's what you're looking for. So what you're going to do is, and this is more relevant in the unstructured data space, where you bring all your documents, and that's really the knowledge that exists within the organization. So each document is represented as a vector, or further chunk down, and smaller document or smaller chunk is represented as a vector. So that is one time you create, and every time you update those vectors, that is then loaded into a vector index or a search index, which is capable of handling vectors. And then as a user, when you're looking for like going back to my query on healthcare, I was looking for eye exam, is it included or not? That eye exam query is again created as a embedding. That becomes my vector of the query. I am now going to look for 2, 3, 4, 5 vector being closest to one of the source vector that is present in my search. And of course, there is one that I can find, and that becomes my result that needs to be sent back to the user. So that's really the play of embeddings and vector searches. Now, this is exactly where Azure AI Search comes into picture. We have different modes of doing the search, the keyword search or the text search, the vector search, which we talked about, but also the hybrid search. Hybrid is ability to mix the two at where you're looking for the phone number or which is needs to be keyword, but for every other information or query that you have, use the vector, and hence combination of those two is hybrid. But not just that, the semantic ranking is additional capability on which we do the second level of ranking. So keyword, vector, and hybrid 3. The semantic re-ranking is the level 2 of ranking and identifying better results from all of this. So which means your responses to users are going to be a lot more relevant. And the semantic ranking is really dry. You can see that when we compare all of these different modes of searches, how accuracy improves over time. So from keyword to vector to hybrid, and then hybrid with re-ranking, significantly increases the accuracy of your search system. So it's very important that the search mechanisms that you're using is able to cater to your different scenarios, but not just that, it is providing semantically more and more relevant and accurate information. Along with that, of course, the ability to connect with the data sources, crack different file format, crack open, extract data, do chunking large documents, and ability to find the right chunks within that, but through vectorization. And eventual vectorization is embedding, which means embedding API within the search, integrated embedding API, and then indexing that data inside the search index. So that's really what the knowledge and search aspect is. Now there are other ways you can also integrate with your organizational data. Drag is one that we talked about, and vector search is a way to enable that. The second is using a function or a direct API, and in this case specifically, at times you, for example, looking like scenario like, hey, what is my account balance? At that time, you're better off calling an API backend, to the backend database, and for this you're going to use something like function calling, which is available on Azure OpenAI. The third is, of course, agent, which is a lot more complex task. And here you use multiple models, chain multiple APIs to solve a complex problem. It's not just retrieve one, let's say balance from using API, retrieve some information from using RAG from internet for relevancy or recency, plus your organizational data, do some more, massaging. Maybe you need to make another call to another system like CRM system, and then eventually serve that. And that's really the workflow that is made possible through Assistant API on Azure OpenAI again. Apart from search, of course, the operational databases are very critical, very important aspect of building any application, intelligent application. So we have relational, non-relational databases, so including not just SQL Server based, but also open source based databases like PostgreSQL, MySQL. We have Oracle on Azure. And then, of course, non-relational databases like MongoDB, Mongo Atlas, Azure Cosmos DB. So non-relational will be very important because a lot of AI scenarios, you will see the responses coming out as JSON. Are you going to process that and store? Or you're just going to store, you have the capability to store JSON as well, and ability to validate that JSON across, again, some schema, or depending upon scenario, you might just need the flexibility, so you can do that. You need to probably maintain a chat history. You can also create vector databases and vector searches, include, on Azure cache layer like Azure cache for Redis is very important for building fast, experience for your end users. Now, the third aspect is what principles and tools, or the overall aspect of trust, what tools or principles should I be using or building on to protect my people, internal or external. And honestly, generative AI has introduced new set of risks, but we are addressing that as we go. First is, of course, whether your responses are grounded or hallucinating, and we talked everything about RAG, but not just that, ability to check if the data, if the response is grounded. The jailbreak attempts and ability to detect that and stop that, the harmful content, and if there is a content getting generated, could it be the IP, somebody's IP that is getting generated? Could there be infringement claims on that? And sometimes AI actually acting like human life. We of course do not want people to think that they are talking to an human when they are talking to the AI agent. So ability to detect and address all these is going to be very, very important to building trust in the AI systems or the copilot that you're going to be talking about. So the first is, of course, different aspects of detecting harmful content, groundedness detection, detecting for jailbreaks. That's a super, important aspect. The second I talked about the contents, whether there is any harmful content, whether sent by the user or generated. And then on the copyright infringement aspect, Microsoft itself has made a commitment to if there is a IP infringement lawsuit on customers, there is a financial or legal aspects arising out of that. Microsoft will take care of that and reduce the liability. So that's really how we're committing to this entire, to build trust in AI systems. And by the way, there's a lot more work which is being done by research, which is not yet covered here. Now, but let's look at what are the different risk mitigation layers that are, that need to be taken care and how it is being taken care. The first is, of course, model related itself, right? So choosing the right models. And as we've seen over time, models are becoming better and better. The hallucinations have stopped. There are ways to control, model behavior. One, by giving the the prompts or the boundary boxes for those models, and that's really grounding on your own data. So there are ways to control that, and all that is what we use is now available to all the customers, to all the enterprise. The second part is the safety system, that user input as well as the output that is generated is safe. So one, we have built-in content safety filters which are built into the overall workflow, but also provide that as a way for you to integrate in your own workflow. So that's the safety system, and then system message and grounding, and eventually the user experience. So these are different layers and model system safety, etc. Some is Microsoft controlled, some system message and grounding. Yeah. Like I said, these are ways we have enabled. System message is what you're defining as a prompt for the Copilot or the LLM, and hence you have full control on that. Grounding on your own data, you have full control on that. We have mechanisms to enable that, and then mechanisms to test for groundingness. And of course, user experience, ability to show why a certain response was generated, whether it is, ability to give feedback. User should be able to give feedback. So we should be looking at multiple layers for, driving the risk mitigations. Specifically on content safety side, we talked about the quality, groundedness, coherence, relevancy, etc. So one, you should be able to check for the out-of-box models, and we enable that in Azure AI Studio. The second is ability to test that on your own data using the workflows. The third aspect, like I said, is the risk and safety, which is jailbreaks, all hateful content, violence or self-harm. So ability to detect and prevent this, both for input and output, and then also customize that for your own scenario. So the content safety framework is comprehensive and is available within Azure AI Studio, and we'll talk about that as we go. But here is a quick demo of, let's see what we're talking about.
Azure AI Content Safety is an API-based product that can be deployed as part of any application to monitor for harmful content in real time. I'm in the studio so that we can explore how it works interactively. For the Contoso bot, most people are going to be asking appropriate queries about products they'd like to buy. For example, here's a user query looking for an axe to cut a path in the forest. If we ask Content Safety to score this, we can see that it recognizes it as safe. However, one of the challenges with language is that small changes can completely change the meaning. But the power of new foundation models and Azure AI Content Safety is that it can understand these differences. So if I change even a single word in the sentence and rerun the query, you can see that Azure AI Content Safety understands that this query is not safe and it would reject it. Here, I'm using the default settings, but if I want, I can adjust the severity levels to meet the needs of my application and deploy this through the API in production. Contoso uses Azure OpenAI, so Azure AI Content Safety is already built in. Returning to the Contoso bot, I can test these same queries again. Here, I'm going to start with a recommendation for cutting a path. As you can see, the Contoso bot is prepared to recommend products the customer can buy. However, if I pretend to be a user with the same harmful query as before, I can see the safety systems in action, and my bot knows to reject it, protecting Contoso and its users.
Right. So that's about building trust through responsible AI principles and tooling that is, built into the models, built into the platform, and is available to you to build. Now, the last aspect of this is how do we really streamline operations? So, for a regular application development, there are, DevOps aspect for a machine learning model, machine learning team that or data science team, there are machine learning operations or ML ops capabilities. But for LLM or the generative AI applications, there are different considerations, and we need to one understand that. Second, to be able to take care of that. The first is orchestration, ability to create prototypes, use different kind of prompts, different kind of models. The second, so how do I integrate? Be ability to should be able to chain different prompts. We should be able to optimize retrieval. All that is about orchestration, and we saw some of that. You'll see going forward. The second aspect is evaluation. So while you are prototyping, you're just going to be probably using anecdotal. But from prototype to production, the requirements are significantly different. One is you should have a data set, should be able to evaluate on that data set, and should be not just able to evaluate, but also see certain metrics that you can trust, be it in terms of accuracy. So there's a golden data set. You should be able to evaluate your, either the model change or the prompt change. In either of the scenarios, you should have a workflow that you can go ahead and test and quickly say that, hey, by the way, this metric has either deteriorated or improved, and hence should be able to take a call. Likewise, considerations on performance and cost. What is the best model? How do I optimize for latency? At times, choosing a simpler model may be sufficient, like a GPT 3.5 rather than a GPT 4, because GPT 4 is a much larger model, larger number. It's a complex model for advanced reasoning. Maybe for every scenario you don't need that. SLM or a LLM, whether do you need a fine tuning? So ability to address all of that. And then, of course, the compliance of whether there is a public data or whether there's a PII data, non-PII data, and how do I address security, safety, and compliance aspect. So these are all the aspects that you want to take care as you build applications or copilots in your own enterprise scenarios. So first is ability to develop iteratively, trying out different prompts, not just heuristically, not just like I said, able to create different prompts and test it anecdotally, but a systemic workflow to do that. Second is continue to refine that and adapt to the human feedback, and then responsible AI altogether. Let's quickly look at prompt flow, which is a framework built into Azure AI Studio for testing different kind of prompts and evaluating.
I'm going back to the Contoso retail flow to experiment with the meta prompt and add the safety section I just showed you. Okay. Rather than just push it to production, I also want to test it first. Built into Azure AI is a system for testing prompt variants. As you can see, I'm testing two variants here. Variant 0 contains the new safety section. Now I'm going to use prompt flow to see how these two compare. Prompt flow provides built-in metrics, which makes it easy for me to evaluate. Let's look at the results. First,
sorry about that.
I'm going back to the Contoso retail system to understand how these two prompt flow provides built-in metrics, which makes it easy for me to evaluate. Let's look at the results. First, I'm going to look at the outputs of the system to understand how these two prompts stack up qualitatively. I can see immediately that there are differences in how they behave. And if I go to example 3, which is the example of a user trying to jailbreak the system, I can see that variant 0 outperforms variant 1 because variant 0 refuses to give information about its prompt, while variant 1 is successfully jailbroken. Now that I've looked at the examples, I want to understand how these two compare overall by looking at metrics. I can see that variant 0 is outperforming variant 1 across the board, with higher scores in groundedness, relevance, and coherence, which means it's the clear winner for me. And now I can confidently deploy to production and bring the power of AI to Contosa.
So you got the drift of how prompt flow is going to enable LLM ops aspect of testing different prompts and testing against your gold standard database and testing for specific matrix that are going to help make the decision of moving the changes to production, either changes in terms of prompts or it could be changes, like I said, a new model itself. So it will enable you for that. Now, Azure AI Studio brings all of these aspects together. This is choice of models, the model catalog that I talked about, code-centric developer experience also available, data integration, ability to integrate with your data sources, to ground your data. Search is integrated. Azure AI Search provides retrieval capabilities for through vector and semantic re-ranking. The full development lifecycle that we talked about, and then the entire content safety and classification, jailbreak detection, and then groundedness detection. So Azure AI Studio brings all of this together, and hence that becomes the cornerstones for building custom Copilot experiences. That's what Microsoft uses. Underpinning is Azure Machine Learning Platform, but that's where I would like to now invite Satish to talk, take us through what the Copilot architecture looks like from an application perspective and from a solution perspective.
Sure. Thank you, Shweta, for taking us through all these details. We'll now look at the actual architecture of Copilot, bringing all the aspects that Shweta spoke about earlier together. Now, what you see in this slide is kind of grouping of various capabilities, right? So when you want to build, let's say, a custom Copilot, a custom Copilot at the end of the day is an application that leverages generative AI models, right? So it uses the generative AI models to infuse AI into your application. Now, this layer here represents those foundational models, right? So within Azure, for example, we have the Azure OpenAI models, and then as part of using AI Studio, you can spin up other open source models as well. Now, you have the foundational models. When you build a custom Copilot, you would also then build a front end to consume the application, for your users to consume the application, right? So that this layer here represents the user interface that you would typically build as part of your custom Copilot. Now, what you see here in between is kind of the core of the Copilot logic, right? So here there are two layers. One is the grounding, the layer that grounds the data. It kind of helps the responses generated by AI to be based on your enterprise or your organizational data. There are a couple of ways to achieve that. One is to embed, create a vector representation of your data, store that in vector databases. The other approach would be to invoke your data sources by creating plugins, right? So that's for grounding the response. And this orchestration layer here represents the layer that applies these various steps, right? So let's take a deeper look at what the orchestration layer does. Now, typically, when organizations or you set out to build a custom Copilot, the focus is on, hey, I want to use these foundational models. Now, these foundational models are going to provide me a bunch of SDKs